Hello viewers, and welcome back to my channel. In today's video we're going to be discussing simple linear equations. In our discussion today, we will learn the definition of a simple linear equations. We'll also know the form of a simple linear equation. We'll go on to discuss examples of simple linear equations and how to resolve them, and then we'll conclude our discussion today by discussing the types of linear equation. I have two definitions for a linear equation. The first one, I will define a linear equation as an equation in which the highest power of the variable is 1. That's an equation in which the highest power of the variable is 1, or what they call a 1-degree equation. That's the first definition of a linear equation. I can also define a linear equation as an algebraic equation where each term has an exponent of 1. An algebraic equation that each term has an exponent of 1, such that when it is translated into a graph, it results in a straight line graph. That is, it's an algebraic equation where each term has an exponent of 1, and such that when a graph is made out of it, it is a straight line graph. That's our definition for a simple linear equation. Now, a simple linear equation is of the form ax plus b is equals to c. The form ax plus b is equals to c. Now, with that, the x is known as the variable, the a is known as the coefficient, and the b is the constant. We also have linear equations in two variables, such as ax plus by is equals to c. That is, ax plus by is equals to c. In that case, x and y are the variables, a and b are the coefficients, and of course c is the constant. And now let's quickly go into examples of linear equations. Let's do an example 1, that is 2x is equals to 12. That is, 2x is equals to 12. Now, the trick in resolving this linear equation is to first of all look for what is the coefficient of x, which is 2 in this case. You divide with that coefficient. Now, whatever you do to one side of an equation, you do same to the other side of the equation. So you divide x with its coefficient, which is 2. You also divide 12 by that coefficient, which is 2 as well. So if you divide that, you don't have that 2x divided by 2 is the same thing as 12 divided by 2. So when you cancel out, results in x being 12 is equals to 2, which eventually is 6. That's for our first example. So in our second example, we're going to use the expression 3 plus 7x is equals to 24. 3 plus 7x is equal to 24. So two things we can do here. First, we'll gather like items on one side and unlike items on the other side. By like items, I mean items that have coefficients on one side and the constants go to the other side. So the trick is that whatever item that is a number or variable goes over the sign of equality, the sign changes. Let's take, if a number like 3 goes over the sign of equality to the other side, it becomes minus 3. Or a number that is like a negative number goes over the sign of equality to the other side, it becomes positive. So in this case, from our equation, we have 3 plus 7x being equal to 24. That will mean that the next line of our equation will be 7x is equal to 24 minus 3, because 3 has gone over the sign of equality as a positive number, so it becomes negative. So you have 7x will become 24 minus 3. That is, a 7x will become 24, which is 21. Now, to resolve for x, as in the first example, you divide by the coefficient of x, which is 7 in this case. So our next line will be like 7x divided by 7 is equals to 21 divided by 7. So when the 7s cancel out and leaves x behind, 21 cancels with 7 into 3 places. So we now have x being equal to 3. That will be our second example. Now, Let's do one other example is 11 is equals to 4 plus 3x. That's the equation. 11 is equals to 4 plus 3x. So in this case, since numbers are on the left hand side and the coefficients and the variable is on the other side, we take plus 4 to the other side of the equation and it becomes minus 4. That will leave us as 11 minus 4 is equals to 3x. 11 minus 4 is equal to 3x. Again, so we now have 3x over 3 will be equals to 7 over 3. That makes as x to be equals to 7 over 3 when divided. That's for our example 3. Let's do one final example to conclude the discussion on linear equations. 3 is the same thing as 2 into x minus 4. That is y plus 3 is the same thing as 2 in bracket x minus 4. The first thing we'll do is to remove the brackets on the right hand side of the equation. Now, removing the brackets from our earlier discussions will make the expression look like y plus 3 is equals to 2x minus 8. That is y plus 3 is equals to 2x minus 8. Now, since it's since you have both y and x and we're looking for y as an expression, we need to move 2x to the other side of the equation. So that will now make our expression look like y is equals to 2x minus 8 minus 3. Remember that plus 3 was on the left hand side because I will move it to the right hand side over the side of equation, so the sign changes. So we have y is equals to 2x minus 8 minus 3. That now leaves our equation as y is equals to 2x minus 11. Y is equals to 2x minus 11. And just before I bring this discussion to a close, I would like to state here that there are 3 categories of linear equations. 3 categories of linear equations. So I will just give the form of each. The first is called the slope intercept. The slope intercept, and it's of the form y is equals to mx plus b. Y is equals to mx plus b. We also have the second type of linear equation as point slope. In a point slope, we'll have y minus y1 is equals to m into x minus x1. That's discussing the gradient, which in our future discussion of graphs, we'll come to discuss the gradient m, which is given as y2 minus y1 divided by x2 minus x1. So it's from that expression that we now have a point slope expression as y minus y1 is equals to m into x minus x1. Now the final type of linear equation is known as the standard linear equation. And the standard linear equation is of the form ax plus bx plus c. Of course, like in our discussion earlier on, ax plus bx plus c have the x's as variables, a and b as coefficients, and of course the c as the constants. In a future video, you'll be watching out for how to resolve simultaneous equations. Of course, that will be like a build-up to what we have discussed in our video today. So as usual, please leave behind comments on the comment section. Let us discuss what you feel we could talk about in this video presentation. And finally, don't forget to subscribe to our discussions so you can have availability for future presentations from the channel, and click the like button if you like what we are doing. Thank you very much. God bless.